Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC27 indicates a malfunction with the steering angle sensor, SAS, in the Honda Odyssey model years 2011 to 2017. This sensor is crucial for the Vehicle Stability Assist (VSA) system, which helps improve vehicle stability by detecting and reducing skidding during turns. It does this by monitoring the position and rotation of the steering wheel in relation to the vehicle's direction. The location of the steering angle sensor is typically on the steering column, making it easily accessible during troubleshooting. When this sensor malfunctions, it can lead to various safety issues, as the VSA system directly affects vehicle handling and stability in adverse conditions. Thorough troubleshooting is essential to identify the root cause and ensure the proper functioning of the vehicle's stability mechanisms. The steering angle sensor, abbreviated as SAS, monitors the angular position of the steering wheel to help maintain vehicle stability. It sends data to the Vehicle Stability Assist (VSA) system, allowing adjustments to be made to brakes and engine power for better handling. Located on the steering column, the SAS plays a pivotal role in ensuring driver safety and comfort by responding to steering inputs. If it experiences a malfunction, the VSA system may not operate correctly, leading to problems like loss of control in slippery conditions. Diagnosing this error is essential, as continued driving with a faulty SAS can compromise vehicle stability, especially during cornering or adverse weather. Several factors could lead to DTC27 being triggered. First, the steering angle sensor itself might be malfunctioning, which is usually due to wear and tear or internal failures. Next, wiring issues such as shorts or corrosion in the connections can disrupt the power supply to the sensor, affecting its performance. Lastly, the condition of the tires is crucial for the VSA system's functionality. Uneven tire wear or improper air pressure can result in inaccurate readings from the SAS. Each of these possible causes needs to be examined to effectively address the error and restore the vehicle's stability functions. When DTC27 is present, several symptoms may become apparent. Firstly, the most noticeable sign is typically a warning light illuminated on the dashboard, which indicates an issue with the VSA system. This alert signals that the vehicle's stability may be compromised. Additionally, the handling of the vehicle may become unstable, especially during turns, leading to a potentially dangerous driving experience. Drivers might also notice that activation of the VSA system occurs in situations where it normally shouldn't, like on dry pavement. Such behavioral anomalies indicate that the steering angle sensor's data is unreliable. Recognizing these symptoms early can help prevent accidents and ensure timely repairs. To begin troubleshooting DTC27, the first step is to turn the ignition switch to the on position, which is often referred to as position 2. This activates the vehicle's systems without starting the engine, allowing for diagnostic processes to occur. Next, it is crucial to record all freeze frame data and any onboard snapshots. Freeze frame data captures key vehicle parameters at the moment when the fault occurred, which can be invaluable for diagnosing the problem. Following that, reviewing the general troubleshooting information specific to DTC27 ensures that technicians are aware of the protocol to follow. This step sets a strong foundation for any subsequent steps in the troubleshooting process. After preparing the vehicle, the next step is to clear the DTC using the Honda Diagnostics System, HDS. The HDS is a specialized tool that provides comprehensive diagnostics for Honda vehicles, including DTC clearing capabilities. By clearing the code, technicians can reset the system and check for recurring issues. Once the DTC has been cleared, it's important to turn the ignition switch fully to the lock position, which deactivates the electrical systems entirely. Following this, the technician should prepare for a test drive. This drive is essential to replicate driving conditions that might trigger the DTC again, facilitating further diagnostic checks if necessary. The third step consists of performing a test drive to gather live data from the vehicle's systems. The technician must drive the vehicle around various corners, simulating real-world driving conditions to evaluate the performance of the steering angle sensor. It is specifically important to drive on the road rather than on a lift, since the sensor's function relies heavily on actual steering input and vehicle dynamics. This step allows the technician to assess whether the steering angle inputs are accurate and whether the VSA system is functioning as expected during critical driving situations. If DTC 27 is indicated again, it confirms the need for deeper investigation into the possible causes. After the test drive, it is essential to check for any DTCs using the Honda Diagnostics System, HDS, once again. This step will confirm whether DTC 27 is present or if it is cleared on its own. If the DTC is indicated, this implies that there is still a malfunction and further investigation is necessary. Conversely, if no DTCs are found, this suggests that the issue may have been intermittent or that the system is operational at that moment. Documenting this result is vital as it informs subsequent steps in the troubleshooting process. This continuous monitoring of the system is crucial in determining whether the vehicle will require parts replacement or extensive repairs. In the fifth troubleshooting step, the technician should assess the condition of all 4 tires on the vehicle. Tires play a significant role in the VSA system's performance, helping the steering angle sensor provide accurate data. This includes checking the size, air pressure, and amount of wear on each tire. Proper tire pressure is critical, as underinflated or overinflated tires can mislead the sensor readings, leading to erroneous fault codes. Additionally, signs of wear, such as uneven tread or damage, must be analyzed. If any issues are found, the technician should replace the tires or adjust the pressure accordingly. After making these adjustments, a recheck may be necessary through another test drive. Following the tire condition assessment, the next step is to turn the ignition switch to the lock position. This action ensures that all electrical systems are powered down and safe to work on. Subsequently, the technician needs to disconnect the steering angle sensor, SAS 5P connector, which will allow for further electrical testing. It's essential to handle connectors with care and ensure there's no corrosion or debris affecting the connections. After disconnecting the SAS, the next step will involve checking the VSA modulator control unit, which is crucial for the operational integrity of the steering system. Proper preparation for this step ensures accurate measurements during the next phase of troubleshooting. Next, the technician will proceed to disconnect the VSA modulator control unit's 32P connector. This component is responsible for processing data from various sensors, including the steering angle sensor, enabling the vehicle's stability management functions. Once the connector is detached, the ignition switch should be turned back to the on position. This action will provide power to the system, allowing for voltage measurements to be taken. Afterward, the technician will access specific terminals within the VSA modulator control unit. Terminal numbers 13 and 25 will be measured for voltage. It's essential to conduct these measurements carefully to obtain reliable data that will guide the next steps in addressing the fault. At this stage, technicians will measure the voltage between body ground and VSA modulator control unit terminals 13 and 25 individually. This step assesses whether the electrical supply to the SAS is adequate. Technicians are looking for a reading of 0.1 volts or more, which would indicate that the wiring is intact and there's no short to power. If the readings show appropriate voltage, it confirms the wiring's functionality and leads toward diagnostic steps focusing on the sensor itself. Any failure to meet this voltage threshold would suggest repairs are needed to rectify a potential short circuit in the wiring that connects the VSA modulator control unit to the SAS. This step is critical to understanding the health of the electrical system as it pertains to the SAS and VSA system. In the next troubleshooting step, technicians will measure the voltage between body ground and VSA modulator control unit, terminal numbers 15, 24, and 27. This will involve checking each terminal individually to gather a comprehensive electrical assessment. Proper attention must be given to the pin configurations, ensuring that the measurements account for any variance in how they connect within the circuit. Each reading will provide insights into the condition of the electrical circuit and whether the VSA system is receiving adequate information from the SAS. Misreadings or absent voltage at these terminals could suggest wiring issues or sensor failures, prompting further investigation into each component's functionality. This step serves as a backdrop for confirming the integrity of the system, leading to the SAS. After completing any necessary repairs or replacements, a final verification is essential to ensure the system's functionality. The technician should conduct a test of the vehicle's systems to confirm that the DTCs have cleared and that no further error codes are indicated. It's also crucial to evaluate the vehicle's stability by simulating various driving conditions similar to the original issue reported by the driver. Checking the performance of the VSA system ensures that it operates smoothly and safely without any lingering faults. The ultimate goal is to restore the vehicle's handling characteristics to a state of reliability and safety. This verification step is paramount before returning the vehicle to the owner. To prevent DTC 27 from recurring, regular preventive maintenance practices should be observed. This includes performing routine tire inspections that ensure proper air pressure and uniform wear, as tire condition directly impacts the VSA system's reliability. Additionally, monitoring the functionality of the steering angle sensor is vital. If drivers notice any handling inconsistencies, they should report them immediately for inspection. Routine checks of the Vehicle Stability Assist System should be performed in line with the manufacturer's recommended service intervals. Staying proactive with these maintenance tasks will help in identifying potential issues early on, ultimately enhancing vehicle safety and maintaining optimal performance. In conclusion, effectively diagnosing and addressing DTC 27 is essential for maintaining vehicle safety and stability. The troubleshooting process involves a systematic approach, starting from initial data recording to performing electrical tests. Following the laid-out steps accurately is key to understanding the intricacies of the steering angle sensor and VSA system. Problems in either of these systems can severely impact handling and safety, highlighting the importance of thorough inspections. Regular preventive maintenance can go a long way in avoiding future problems. Implementing a culture of timely diagnostics and vehicle upkeep will empower drivers to enjoy a safer and more stable driving experience. Please like and subscribe to the channel. See you next time.